7.9 is special products of binomials. It helps kind of explain what's going on in some of the things visually, and some of the stuff you might look at and think, well, I'm not really going to use that. It does come in handy down the road. So I'm going to start with a drawing. And if we were to go through and kind of cut it up like this, so cut it up something like that. What I want to try to show is kind of what's going on when we're doing this like a binomial times a binomial. So all this section here is going to be where you have like a two-term thing times a two-term thing, like a x plus 2 times 3x plus 7, or x plus 2 times x plus 2, something like that. And for the length, I'm going to say here that I have that larger part there is a, the smaller part's going to be a b. Then you could do that same thing across the top, that would be an a, and this would be a b. So if I were to try to get the area of this whole thing, do you agree the area of a rectangle or a square is just the side length squared, or it's going to be, in this case, a plus b is the length of a side, right? So I have a plus b times a plus b. So that's my area. Well, if I were to just look for the area of this part here, that's going to be a times a, or a squared. If I'm looking for the area of this part, that's going to be b times a, but we'll write it alphabetically, so we'll say that's going to be a times b. If we're looking at this part here in the upper right, that's going to be a times b again, because we're a tall and b wide. And the last part, that little corner, is going to be b squared, or b times b. Nice. So if you want to get the area, you could take and add those four chunks together to get the area of that whole thing. So my area is going to be a squared plus ab plus ab plus b squared, right? And if we were to take, so to tie this into yesterday, if we would take this problem here in FOIL, when we did the first times the first, we get a squared. We did the outside, we get a times b. Inside would be another a times b. Last would be b times b, or b squared. And whenever we FOILed, you were able to take these two middle parts and combine like terms. So the area ends up being just a squared. Now I have two of these ab's, so plus 2ab plus b squared. You kind of with me? What kind of happens? So it's supposed to be a 2. No, it could be a more clear 2. So what I want to do is now I want to take and try to tie this into two formulas. So Roman numeral 1, perfect square trinomials it's called. So perfect square trinomials. And this thing right here, the a squared plus 2ab plus b squared, or my drawing that came from, is a perfect square. It's perfectly a square. It's a square shaped. And it's a trinomial because we have two parts. We have the a squared, the 2ab, and the b squared. There's three different terms in there. So perfect square trinomials. They come from squaring a binomial. That really, in this original problem, you could say this a plus b times a plus b, that's the same as a plus b quantity squared, right? So squaring a binomial is going to give you one of these perfect square trinomials. And maybe I'll quick write that down. You could say comes from squaring a binomial. And if you can kind of picture that square, that's going to make things make a little bit more sense later. Okay, here's two things that are worth memorizing, although initially you're probably not going to see the point. But the first one is going to be a plus b in parentheses quantity squared. So a plus b quantity squared. That's the problem that we just did over here. I had a plus b times a plus b. So that's just going to equal this part right there. So it equals a squared plus 2ab plus b squared. The most common mistake that I see people do, so I'm going to quick throw this out there now, is that people see this original problem, this a plus b squared, and they want to just say, oh, that's a squared plus b squared. But it doesn't, right? We also have this plus 2ab. And the reason, I wouldn't write this right now, but the reason is a plus b quantity squared is saying it's a plus b times a plus b. And then we have to FOIL. You can only distribute the 2 inside. What would have to be between the a and the b in my parentheses there to just say it's a squared and b squared? Right there we had to have If it was multiplication, you could do it? Okay, we'll see that coming up soon. All right, next one. If instead I were to have a a minus b quantity squared, you're going to get the exact same answer with one tiny change. If I do a minus b times a minus b, we won't actually go through and do it right now, but I'd have a squared, so I'd do a times a. The only difference is this minus sign. It's a minus 2ab, and then a plus a b squared. So these here are going to be pivotal for later, and maybe I'll even try to change the color a second on just that one part. The only difference is if that's a plus, this is a plus. If this is a minus, this is a minus. But other than that, the a squared, the 2ab, and the b squared are all the same. All right. Let's go down and do some examples. These examples, you can apply one of those things in that red box, but most people I found don't. It's probably easiest just to not do it that way. But x plus 4 squared. I'm going to leave myself some space. If you want to apply that thing inside the red box, my x is really like my a value, right? So where here I had a right there and an a right there, you could do that same thing, but now it's an x. So my first term is going to be an x squared. My middle term here is going to be a plus, and then 2 times a times b. Would you agree a is like my x value, b is like my 4 value? So it's plus 2 times x times 4, which ends up giving you the same as 2 times 4 times x. So you end up getting a plus 8x. And then last but not least, here we had a b squared. Well, b is that right there, which is our 4. So 4 squared is 16. I'm guessing there's a bunch of people that probably didn't follow that. I probably wouldn't my first time around. So here's the easier way. We'll probably just do it the easier way until you get more comfortable with it. But do you read x plus 4 squared is really x plus 4 times x plus 4? And now if we were to FOIL that, I do my x times x. That gives me my x squared. Then we do the outside, x times a positive 4 gives me plus 4x. Still good? Then we do the inside, we do positive 4 times x gives me another plus 4x. And then we do the 4 times 4 gives me the plus 16. If I take that and combine these two together, do you agree I get 8x? And I think that second way is easier. Who prefers the first way? Okay. Most people not. So second way better? Okay, so we'll just do a couple maybe that second way, and we're getting close to being done. So if I say example here, so I want to say a x minus 6 quantity squared. I'm just going to skip doing it that first way. And I'd be glad to help you one-on-one if you wanted to, but that's a x minus 6 times a x minus 6. And when you have that, you have to FOIL it. You can't say x squared plus 36 or x squared minus 36. Okay, when you FOIL it, x times x is x squared, so that's my first. Now I do my outside, my x times a negative 6. Minus 6x. Okay. And then I already did that one. So now I could take and do my negative 6 times x, gives me a minus 6x. And then negative 6 times negative 6? Plus 36. That last term is always going to have to be positive if you have a binomial squared. Then final answer, we take this and combine the two middle ones, the outside and the inside. We end up with x squared minus 12x plus 36 for a final answer. Questions on that? Another quick example then. I want to do that same thing but make it uglier is really what it's boiled down to. So pretty much. Well, I prefer to look at it as though I'm trying to prepare you for what's coming next, not trying to torture you. But I'm sure it maybe feels like torture sometimes. All right, if I have 3x plus 8y quantity squared, that's going to be 3x plus 8y times itself. So 3x plus 8y times 3x plus 8y. 8y. And I'll try to color code stuff. So when we FOIL, we do the first times the first. 3x times 3x is 9x squared. Yep, because we have 3 times 3 and x times x, so 9x squared. Then we do outside, so 3x times 8y gives me positive, what's the number? 24. Nice, 24xy. Then we could do the inside, so the inside will be 8y times 3x, so 8 times 3 is, yep, so plus 24. And then we still write it alphabetically, so it'll be xy, even though in your head maybe you came up with y times x. And then the very last clump is going to be, last times last, 8y times 8y is plus 64y squared. Everybody see where those came from? And then from there, you could combine the outside and the inside, and you have your 9x squared plus 48xy plus 64y squared. So a little bit more practicing with the foiling. What I probably should have been doing is going back to that original term, and you could write this, you could skip it if you wanted to, but we said if you wanted to apply what we did at the beginning, a plus b, well then we said our final answer was a squared plus 2ab plus b squared. So if my a is 3x, 3x quantity squared gives me the 9x squared. The 2ab is going to be 2 times 3x times 8y, so 2 times 3 times 8 is 48, and x times y gives me that middle part. And then last we'd have the b squared, which is 8y times itself. 8 times 8 is 64, y times itself is y squared. So that's kind of where I was trying to go with it. All right, the very last equation thing you're going to get is going to be this here. If you have a difference of squares, they call it, so if you have a plus b times a minus b. If you were to have that, I want to just write the nice thing right there, but I'm going to kind of try to get to it in a slow way. So if we were to FOIL this thing here, I maybe wouldn't do the FOILing, but when we FOIL, we do a times a, right? Which is a squared. Then outside is positive a times negative b, minus ab. Then we do the inside, which would be plus ab. And then last is going to be positive b times negative b, minus b squared. And just like always when we FOIL, you can take those two middle terms and combine them. So if you have this thing here in red, which maybe I'll try to get rid of my blue lines, so I can do that without hacking it up too much. What does that thing actually equal? Well, it equals a squared. This part right here, minus ab plus ab, what happens there? Just cancels out. So you get an a squared, and we still have the minus b squared. So if you wanted to apply this, we'll just do one quick example. You could, if you had a problem like a x plus 2 and an x minus 2, you could go through and FOIL it like normal. There's no problem with that whatsoever. The fastest way, though, is to realize, okay, do you agree my a value is my x, and my b value is my 2? So you're going to get a squared, which is x squared, minus 4. So that one's definitely easier to do in your head. So some people are just going to FOIL. There's absolutely nothing wrong with FOILing. The real advantage is down the road, we're going to try to get you to do this backwards. We're going to try to get you to say, okay, x squared minus 4, what does that have to equal? And you have to be able to come up with that. Or the thing is, it sounds terrible, but you'll be ready for it. I'll get you ready for it. Or something like this. This is going to be on the far end of the nastiness, but you'll get something like that in that thing, and you'll be able to go and change it to that. So don't stress about it now. It's actually a lot easier than you think. So don't stress about it now. But that's kind of why we're teaching this now, and that's it.